Hello and welcome in. Mark here, aka the Markster. Today we're going to be looking at the ThreadProfile workbench. So I'll show you how to make threads today using that workbench. I'm using 0.19 revision number 19758 on Windows 10. This is the latest pre-release version. So to use this workbench, you're going to have it installed. So you go to the add-on manager in the tools menu. You'll be in the workbenches tab. Come down and look for ThreadProfile. Install that one, and then you'll need to restart. It'll tell you to restart FreeCAD. So you might want to pause the video and do that. Alright, and then we'll switch to the ThreadProfile workbench. This creates the toolbars. And we're going to go to part design. This also works in part. Let's create a sketch. I'll show you how to make an internal thread first. I'm going to add this hexagon, and I'm at a circle, just any little size, it doesn't matter. And before we pad that, let's add a thread profile. So we have two thread profiles to choose from. We have the V threads and the buttress threads. Let's do a V thread. We want to select in here the internal mode to do an internal thread. And we select the size and the V-thread presets, or you can enter your own minor diameter and pitch if you like. But we have some presets here. Hopefully I put all these in there correctly. This is M20. Fine. It looks like it's going to match up well. I'm going to map the thread profile to the circle that we made in the sketch. Concentric. Now we can pad the sketch. Select the V-thread profile. Choose the make a helix object. If you're in part design and you have an active body, and then a shape binder will be created, a helix and a shape binder to it. So we select the V-thread profile and the shape binder and select the sweep tool here. For internal threads, this will do a subtractive pipe to cut the thread. For external threads, it'll do the additive pipe. So just use this icon here, or you can, use these tools and set it up like that as well. But this automatically puts the shape binder as the object to sweep along, and sets the freenet or frenet mode. So give it a moment, don't give up on it, and it'll come on up here shortly, hopefully, in the preview window. And we'll hit OK. And notice it did not hide the cancel this. It did not hide the pad. So we need to hide the pad and hide the shape binder. There's some change in 0.19 when the link merge code was added that is no longer automatically hiding these. I'll have to try to figure out what's going on with that. Hopefully there aren't any other bugs, but there could be. So that's how we could cut threads in part design. You hide this body. Create another body. Let's do the external thread now. Let's try buttress thread. And we'll do the external. For some reason in 0.18 we get a face here, and since the link thread merger added these links capabilities during the development cycle, we're not getting a face anymore, but it still seems to be working. If you have problems, try it in 0.18. Or if you have one of the builds that came out before the link merger, try one of those. I'm gonna see if I can figure out what's going on with this and try to get it fixed. But in the meantime, let's select the external, and these buttress presets, these are only inches, so this is there are no metric in here, but if you wanted a millimeter, you can just put it in here in the diameter and the pitch that you want. So I'm going to choose 2-inch 8 threads per inch. So it's 2-inch diameter. You can see the monitor diameter updated. 8 threads per inch. So 1/8 of an inch per pitch. The next thing is to create the helix, which again produces a shape binder. Select the shape binder in the thread profile and click the sweep tool. So these buttress threads are designed as kind of a one-way thread where the strength is focused in one direction, so it's not as strong in the other direction. This can be, I think, good for 3D printed threads because they're already kind of weak because of that plastic material. So if you can focus the strength in the direction that you needed the strength in, which usually is just one direction, you can maximize the strength of the thread. Another thing I like about it for 3D printing, which I haven't actually tried yet, you'll see when it comes up here, the way the thread is designed, if you print it in one direction, let's go ahead and make it. If you print it in the opposite direction from what we're looking at here, you could do it without support, which support with threads is problematic anyway, because it's really tough to get that support out between these threads. So with this 45-degree angle, you'll have a better chance of printing this without support and not having problems, because as your layers move up, It's not too steep of an incline. But if you print it in the other direction, then you would have the opposite situation. But you have a lot of overhang here. I think it's a 7 degree by 45 degree is what this profile is. The external thread is made just a little bit smaller than the matching internal thread to give you a little bit of clearance. This is all automatically done for you in creating the profile. But you might adjust it if you find it's too tight or too loose. Just come in here and try to tweak this minor diameter. So if it's too tight of a fit, that means the external is a little bit too big. Or if you want to adjust the internal, you need to make it a little bit bigger. Make the internal a little bit bigger, or the external a little bit smaller to try to match it up. You're probably not going to find off-the-shelf components that this will match up with unless you can find the American standard sizes. This profile, I don't think this made in metric. I could not find any specs for this particular profile that had metric settings. So that's why these are all American standard settings. Now in the V threads, you do have metric coarse, metric fine, and you have UNC and UNF, which is the coarse and fine for the American sizes or the imperial sizes. So that's with part design. It can also work in part workbench. We just choose our thread profile. I need this knot inside of a body. If it finds an active body, that's when it creates a shape binder. When you create the helix. Create our helix. Now no shape binder, you see. Now if you do an internal thread in the part workbench, you'll need to cut that out of some other object. It's going to create a regular sweep, but you'll have to cut it out of the object yourself. In part design, if it's an internal thread, it will create the subtractive pipe for you. So let's look at the V-thread presets. One of them that we have is the garden hose NHR. This is the standard garden hose used in the United States. I don't know if it's the same as what's used elsewhere. I don't think the garden hose thread is actually a V thread, but this is close enough. Matches it up pretty well. So let's choose that one. And we select both of these and use the sweep tool here. The helix radius does not matter. It does not have to match the profile radius. The pitch is what matters with the helix. So this is a garden hose external thread, I believe it was. Yes. So we can make also a garden hose internal. Use the internal here. Go to the presets. Choose the garden hose. Let me show you the other presets while we're here. So we have the metric coarse, then the metric fine. You keep on going, you'll get to the UNC coarse and UNF fine. Or you can just enter your own minor diameter. All you need is the minor diameter and the pitch. It'll calculate the major diameter for you. So we're going to do the garden hose thread internal for this one. So we select the profile, select the helix, select them both, and do the sweep. Now this internal is going to be just slightly bigger than the external. I'm going to fuse them together just for the purpose of creating a cross section so we can see how these threads line up together and what sort of clearance that we have. It's a little bit glitchy with this latest 0.19. If you run into problems, try 0.18. Something about this link merger, something code changed somewhere in FreeCAD that has kind of introduced some little glitches. And it seems to be one of those intermittent things, really tough to track down. Anytime you're working with a helix, it's going to be CPU intensive. This is why many times you'll see a professionally made CAD model. It doesn't even have the threads, or it might have just some pseudo thread to kind of look at a glance like threads. It just slows down your computer. And the thread profile object is also a pretty complex object with a lot of data points in it. It looks like a simple kind of off-centered circle, but it's a fairly complex object. Now to improve performance, if it ever finishes, I'll show you something else. I'm going to put it on pause while this is going and come back when it finishes. Okay, that took about another minute or so. In retrospect, I don't think I really needed to fuse them. I could have just taken a cross cut with each one individually. Let's see how this is going to work. Let's take this cross cut and have a look at it. Now keep in mind the external is to be used as is, but the internal has to be cut out of some other object, which I did not do. But let's look at our clearance. It's not showing any because I guess that fusion was a mistake in more ways than one. But let's just do a cross cut of each. Hopefully they'll be lined up. So we take that one on that sweep. I don't remember which one it was. Yeah, the first sweep. And then we'll take one on this one. YZ. And then we'll compare them. I want to show you that there is a little bit of clearance. Hopefully there will be. If not, there is a mistake somewhere. Alright, now we're going to hide these. There we go. So we'll see a little bit of clearance. Notice also these profiles are different. They're not exactly the same for internal and external. One of them has the curve here on the inside at the minor diameter. And well, it's both minor and major, isn't it? Anyway, it's on the inside, and the straight edge this is the external one. So you have the curve in the crest. No, the curve in the what's that called? Not the valley. The trough, is that it? And then the straight edge at the crest, and opposite for the other. So this is the amount of clearance that you have. If it's too tight or too loose, just go in and adjust one of them, one of the minor diameters. Try a slightly different size. Here in the quality section, let's look at the tooltip here. Quality of profile: 1 equals highest, 12 equals lowest. Higher numbers improve performance, but degrade quality. So you got the highest quality, but if you wanted to improve performance, you could change this up to 12, and it would speed it up a little bit at the expense of, the quality of that profile object. Now if we zoom in really close, you see how it's kind of jagged? You don't see that in the cross section. And these are like micrometers. Very tiny. I don't think they're going to affect your 3D printing at all if you print it in 3D on a 3D printer, because you don't have that kind of resolution anyway. I haven't tried printing any, so I don't know for sure, but I don't think it's going to matter for that. And when you look at the cross section, you see all this is pretty good. So I don't know that it's actually something in the model, or if it's just the way it's being rendered. So that's the thread profile workbench. A quick rundown. There's also a fasteners workbench if you're not familiar with that. And with the fasteners workbench, you get ready-made nuts and bolts and what have you that you could add. And these are parametric, and you can tell it to thread this, and it'll thread it for you. So if you're trying to make standard nuts and bolts in the metric sizes, just use fasteners workbench. One thing is different. I don't believe the fasteners workbench provides any clearance. So if you printed an M6x30 screw and an M6x30 nut, I don't know if they would fit together, because if you printed them both, because you wouldn't get the clearance. Let me see. And maybe it doesn't really matter with plastic. You can just force it on through. I don't know. I'm going to make a compound this time and try to take a cross section. Alright. So you see there's no clearance. So these will be really tight. There might be a setting somewhere in the properties to give you an offset right here. So I think that's what this is for, to get around that issue, if I'm not mistaken. But anyway, that's a terrific workbench for fasteners. But they only provide metric as far as I know. So if you need American standard sizes and you don't want to go through the trouble of sketching out your own profile, this will be an option. And because the thread profile object is customizable, you can get minor diameter pitch combinations that just are not available any other way besides customizing, drawing your own sketch, and selecting your own helix. So when you set your pitch on here, the helix is linked to it, and it will change its pitch to match automatically. Thread count is how many threads you're going to have. So the length of your thread is going to be a factor of pitch times thread count. So this is not the millimeter of length, it's the actual count of the number of threads that are going to be made. And that's with the thread profile object. With these, you get to choose your length. M6 by 30 is 30 millimeters long. You cannot customize this. You can only select from preset sizes. So if you needed a custom size, 42 millimeters, you wouldn't be able to do it. But that's good because you don't want to have a project requiring 32 millimeter bolts only to find out at the last minute that they don't make any such thing. So these are the only ones that are actually available. So, but that's going to do it for this video. Hopefully now you understand a little bit more about using the thread profile workbench. There are some glitches in this newest version of FreeCAD. So if you run into trouble, sometimes you run into the coplanar faces issue, trying to cut out of a hexagon, a prism, say, to make a nut. If your thread profile begins at the same spot, you might run into an issue. So try moving the thread profile down a little bit so that it sticks out of both sides. Sometimes that can fix it. Try moving, instead of even number of millimeters, try moving it down or up maybe a quarter of a millimeter. That can help too sometimes if you run into those problems. You can also try rotating a little bit if there's a seam line that's in the way between the other object that you're trying to cut it out of. And If all that fails, try going to 0.18 and trying that. So that's going to be it for today. Thank you for watching, and as always, have a great day.